Hi guys, here we are in lesson 14, module 5, video 1, and today we are finding areas of rectangles and figures composed of rectangles with fraction or mixed number side lengths, very similar to what we were doing in our last lesson, except now we're adding to it, solve real-world problems involving multiplication of mixed numbers. All right, so as you can see right here on our screen, we have a floor plan, and maybe you haven't seen a floor plan before, or maybe you have. A floor plan is basically a map of a house. So you can see here we have a driveway, right? A garage, some open space outside of the house, like the yard, and here is a garden. And then inside of the house we have a living room, kitchen, and an island. We had this before. The island in the kitchen is like the extra counter space that's not connected, right? And then the bathroom and the bedroom. So it's just a small house, a one bedroom, right? And this is the floor plan, and it shows the lengths of the different sides. And as you can imagine, we're probably going to use that to find area today, right? So we're going to solve some real world problems. And could you look at this, and especially the garden? And what do you notice and what do you wonder about the garden? You might be wondering why it's in an L shape, right? We have been working on composite forms in L shapes, but why is the garden in an L shape? Why doesn't it have any measurements? I wonder how big it is. I wonder what we could grow there or what is growing there in our garden. Okay, so in the previous lesson we worked with the areas of tetrominoes. Remember that in lesson 13? And the areas of figures composed of tetrominoes. Because tetrominoes are composed of squares, we can determine the area of any tetromino by determining the area of one of its squares and multiplying by 4. But it's not that easy to decompose all composite figures into squares. So let's look at some composite figures here. And you see, this could be our garden, trying to figure out the area of our garden. We could split it this way, right? We could draw a line here, and then we could have part A and part B. We could figure out the area of each one and then add them together. Or we could draw a line this way, and then we'll have A and B here, right? Or we could figure out the area of the whole thing and subtract this part. Okay, some of it might be your choice, and some of it might be based on what we know, what we don't know, figuring things out as we go. Today we're going to determine areas in real world problems, and we're going to jump right in to number 1 in your book. So please go there now. It's going to look like this a little bit, and you have the directions in your book. It says the drawing represents the vegetable garden behind the house. The owner of the house wants to cover the garden with a layer of compost. If compost costs $2 per square foot, how much will it cost to cover the garden with compost? Okay, and we have the measurements of the garden here. We just didn't have it on the other one, right? And, sorry, my dogs are bothering each other. You can see that I already have it broken apart into 2 pieces. So, something to think about, right? Something else to think about is, how do you want to solve it? How do you want to find the area of this? And in your book for problem number 1, why don't you start working on that and thinking about it? Do you want to decompose it into 2 smaller pieces and find the area of this one and then the area of this one? Do you want to think about the whole thing and then subtract this one? This is where you have some choice, and you can do it the way you want. So think about that. I think I have some math here. Yeah, already written up. So this method has 9.5 times 3.5. So where did that 9.5 and 3.5 come from? That would be here and here, right? Remember, length times width equals area. So we just need one length and one width because it's a rectangle. So this length is the same, right? Our opposite lengths are the same. Yes? So 9.5, 9.5, 3.5, 3.5, 9.5 times 3.5 is going to be the area of that section. And then we also see 5 times 3.5. That came from right here, this side and this side. So you can see in this one, we are finding the area of the larger block, let's call it block A, and the area of the smaller block, let's call it part B, and then adding them together. So we're not dealing with this and subtracting it out, right? That would be another way to do it, which we will be looking at. So 9.5 times 3.5. Remember, we have to break it apart. So 9 plus a half times 3 plus 1/2. That's just rewriting this, okay? We did it a lot in the last 2 lessons, but I just kind of want to make sure you got it. So we write it out so that we can break it apart and distribute it. So we broke it apart. Now we have to distribute it. Now watch. 9 times 3, right? 9 times 3 plus 9 times 1/2. See how I got those two pieces? Then 1/2 times 3 and 1/2 times 1/2. I really recommend writing it out like this so that you can make sure that you got all the parts, or you're going to make a mistake and you're going to miss one of the parts, right? Like a half times a half. Okay, now we do our multiplication. 9 times 3 is 27. 9 times 1/2 is 9/2. 1/2 times 3 is 3/2. And 1/2 times 1/2 is 1/4. Okay? Then 27. And then this comes out to 6 and 1/4. So we have 9/2 and we have 3/2 and we have 1/4. Now to add those together, we have to have common denominators, right? So let's change them all to fourths. 9/2 times 2 over 2 equals 18/4. 3/2 times 2 over 2 is equal to 6/4. And then 1/4, we'll just add them all together. 18 plus 6 is 24, plus 1 is 25/4. How many fourths are there in 25? There's 6, because 6 times 4 is 24, and 1/4. Okay, so that's where that came from. And that's going to equal 33 and 1/4. Hope you're making notes, copying this down, making sure that you understand the steps. If you ever need to, you can just pause me, right? Okay, so 5 and 3 and 1/2. 5 times 3 plus 1/2. We only had to break one apart here because we didn't have two mixed numbers like we did up here, right? Okay, so 5 times 3 plus 5 times 1/2. Yep. Distribute. 15. 5 times 1/2 is 2.5. 2.5 is 1/2 of 5, right? So we're taking a half of 5. That's another way to think about it. Add it together, 17.5. Our total area is 33 and 1/4 plus 17 and 1/2. 1/2 is the same as 2/4. So that's 50 and 3/4, but we're not yet finished, right? If we go back and look at the question, we see that the question says, how much, the compost costs $2 per each square foot. How much will it cost to cover the garden with compost? So we have to multiply it by $2, right? 50 and 3/4 times 2. 2 times 50. 2 times 3/4. Break apart and distribute. 2 times 50 is 100. 2 times 3/4 is 6/4, which is equal to 1 and 2/4. That's 101 and 2/4. Now, 2/4 is the same as 1/2, right? Because 2 is half of 4. We can divide both of them by 2. 1/2 of $1 is 50 cents. So I converted it from fractions into decimals thinking about money, right? Because we wouldn't say 101 and $1/2, right? We would say $101.50. Okay, so this is our final answer. We do need to write a sentence to go with that. The sentence would be, the compost costs $101.50, because word problems have word answers. Okay, so that's one way to do it. We're going to look at another way to do it in the next video, and I'll see you there. Thank you for your hard work, and aloha.